Hi everyone, welcome back to Math 098. So for today's class, we are going to continue looking at our Unit 2 guided notes. Last class we discussed combining like terms, what like terms were, how to look at their coefficients and essentially decide, what operations we're performing, that kind of thing. We also ended class with a mini discussion on what are linear equations. We understood that in order to be a linear equation, each of your variables, if you do have more than one variable, not in the same term, each of your variables have to have at most a power of 1, meaning it's not going to be a 0, it's not going to be more than a 1. So if your highest power is a 1, you know that your equation is linear. The second you throw in a power of 2, so for instance, like 3x squared plus 5x equals 10, that's going to be a quadratic equation because your highest power seen is 2. And that dictates the power or the type of equation that you have. All right, so as long as the highest power is a 1, we know it's a linear equation, which means it's a line. And we will be graphing lines pretty soon. Excellent, I'm going to check you in, okay? Beautiful. Let's continue with where we left off. I am going to show you how to solve linear equations. I'll give you the rules up front and then we'll do it. But keep in mind, by using those rules, we really can flex our math muscles and go in different directions and try different things as long as we're applying those rules, okay? That's a guideline. Make sure you're not breaking those rules, but we really can play around with how we solve linear equations. Which is why I said last class, you might get a little frustrated with me. You might be like, what the hell? When do I do this? What style should I use? Blah, blah, blah. We're trying to develop each of your own personal styles. I will give you my advice. I will tell you where you might want to go if you're going to solve these equations. So heed my advice, but decide your own style. Okay? Let's take a look. Rules for solving linear equations. Rule number 1, you must, I repeat, you must use the opposite operation to move a term or part of a term to the opposite side of the equals. Opposite operation, opposite side of the equals. Opposite, opposite. So addition is the opposite of subtraction and vice versa. Multiplication is the opposite of division and vice versa. Rule number 2. To keep the equation balanced, you can move an entire term from one side of the equals to the other by adding or subtracting the term, whichever is the opposite. So if on the left-hand side you're adding a 5, you can subtract that from both sides to move it to the opposite, to move it to the right. Okay, you'll see this. Rule number 3. You must multiply or divide every term in an equation on both sides by the exact same quantity. This is really important. If you choose to multiply or divide by a quantity, you have to do that to every single term in the equation. If you have 6 terms in your entire equation and you want to multiply by 2, that's fine, as long as you multiply all 6 terms by that 2. Okay? Keep that in mind. That's the rule. We can add or subtract one term from one side of the equals to the other, no problem. But when we choose to multiply or divide, you've got to do that to every single term. We have to keep this equation balanced. Okay? Let's look at our last rule. Rule number 4, you must isolate the indicated variable. If I want you to solve for x, you got to get x by itself. If I want you to solve for m, you have to get m by itself. That's what that means. All right, let's try this out. That's okay, Gia. Let's check this out. Number 1, negative 10m plus 15 is equal to 34. The first thing I'm going to do is we're going to have the conversation. Oh, we have how many terms? 1, 2, 3 terms. The next thing we're going to know is we want to isolate the indicated variable. If we're going to solve, we're solving for m in this case. So I essentially want to get this term by itself, which means exactly, Hannah, we want to move the 15 over to the 34. Hi, Ashanti. Because this is a positive 15, we're adding the 15. We're going to subtract the 15 from both sides of, or from either side of the equation. If it helps, you can draw a dotted line to separate the left and the right-hand sides of the equation. That's totally up to you. I'm going to leave this clean and just write it as minus 15, minus 15. Notice I'm doing this in column form. This is just my advice to you. As you work through these problems, move in a column form, okay? A positive 15 and a negative 15, these are opposites, which we learned is another way of saying additive inverses. So they cancel. They leave you with 0. You're going to bring down your negative 10m. You're going to bring down your equals. And then 34 take away 15. Well, if we have 34 and we take away the 15, we're actually going to get 19. So far, so good. Notice that as we move through this problem, we're bringing terms down that we did not even touch, right? Negative 10m, we bring it down. Equals, we bring it down. 34 minus 15, we do it. We perform the indicated operation. Last step, Hannah, you're exactly correct. We want to get m by itself. This reads negative 10 times m. That's what that says. The opposite of multiplication is division. So notice in rule number 1, we must use the opposite operation to move a term or part of a term to the opposite side of the equals. Well, negative 10 times m, we want to break that apart, so we want to divide by negative 10. The opposite of multiplication is division, okay? That's why we divide by a negative 10. We wouldn't divide by a positive 10 because we are not adding a 10. It's not being subtracted. So we have to be super careful what we're actually taking the opposite of. The opposite of multiplication, division. Negative 10 divided by negative 10 is a positive 1, which means we could write 1m or simply m. It's up to you. If you'd like to write a 1 in front of there, you totally can. Next, notice with the fraction 19 over negative 10, we cannot reduce that fraction. I do not want a decimal. If you wrote down a decimal, erase that. Okay? Make sure you're leaving your answer in reduced fraction form if it is a fraction. 19 over 10 can't be reduced. We're going to bring the negative out front, and we'll write that m is equal to negative 19 over 10. In terms of the negative sign, I'm going to teach you a little bit of math etiquette. That negative should either move to the numerator or in front of the fraction. That's my advice. Never leave your negative in the denominator of a fraction. Always move it up. If there are two negatives, you know two negatives, they cancel out, leaving you with a positive. And that's if you're multiplying or dividing. So if you have a fraction with a negative over a negative, those negatives will cancel because you're dividing. Okay? Let's go back. Beautiful. Number 2. We have 3 over 4y plus 7 is equal to negative 11. Right off the bat, again, how many terms do we have? We have 1, 2, 3 terms. This 7 and negative 11, these are like terms. So they want to be combined, but we also want to isolate our term with y because we're solving for y. So that means we want to bring the 7 over. Take the term and move it away from the term that you're solving for. Keep that in mind. You want everything to go away from the term that you're solving for. So we're going to subtract 7. We subtract 7 on both sides. And notice these opposite terms cancel each other out. We're going to bring down the 3/4 y is equal to a negative 11 minus 7 is a negative 18. Remember? Negative 11, negative 7, negative 18. Think of it as you owe $11 and then you're like, shoot, I owe another 7. Like, okay, altogether I owe 18, right? Think of it in terms of money. Now, here's where we can get fancy. If we wanted to solve for y, we could divide by the coefficient, right? Because this says 3/4 times y is equal to negative 18. So I could divide both sides by 3/4. Or I could multiply both sides by the reciprocal of 3/4. So notice in rule number 3, you must multiply or divide every term in an equation on both sides by the exact same quantity. So I want to encourage you to try something like this. So let's say I wanted to get rid of this 3/4 coefficient. I'm going to multiply by 4/3, the reciprocal. What you do to one term, you do to all the rest of the terms in your equation. So this is a times. Notice here, excellent, Hannah. Notice here, and thank you, Noelia, that 4 goes into 4 once, right? 3 goes into 3 once, and you're left with 1/1 times 1/1. And if that's the case, that's just a 1, so it's 1y, or you could just leave it as y. Now on this side, we have -18 times 4/3. Every integer is going to be placed over a 1. So now we can reduce. So I'm going to rewrite it so that it's not cluttered, and I want you to see it. So this is our side work. And notice that we're going to say, oh, 3 can go into 18, 3 into itself once, and into 18 6 times. -6 times 4 is a -24. And that is your final answer. Excellent job. Excellent work. There are other approaches we could have taken. This is just one of them. Okay? So as an example, just to show you, I'm going to rewrite 3/4 y is equal to -18. If you wanted to, you could have divided both sides by 3/4. Okay, so far so good. This is what you're used to. Notice 3/4 divided by 3/4 is 1, so that leaves us with a y. And if this whole piece is weird, don't you agree that this is a -18 divided by 3/4? And Hannah, I totally get it. That kind of stuff happens all the time, but I'm glad that you're catching it. So we have -18 divided by 3/4. Well, we know how to divide fractions. We keep the first fraction and we multiply by the reciprocal of the second fraction. And then we reduce before we actually multiply. So notice that perspective. So essentially, we're getting to the same result, just taking a slightly different approach. Let's take a look at number 3 so that we can, again, take a look at a different approach. So we have -12/13b minus 2/3 is equal to 22. First things first, notice how many terms we have. We have 1, 2, 3 terms. Our first term is a -12/13b. Our second term is a -2/3. Our third term is a 22. Now, here's the interesting piece about this particular equation. Notice that we have fractions. If we want, that's okay, Rachel, if we want to simplify our lives and we want to apply rule number 3, which is you must multiply or divide every term in an equation by the same quantity. Keeping that in mind, we can get creative. Notice that we have more than one fraction in our equation. And we could do this with one fraction as well, but I just want to show you why this is so nice. We have more than one fraction in this equation, and they have different denominators. I would urge you to consider using the LCD as that quantity you multiply by. I want you to think about the fact that, that's okay, Maria, think about the fact that if you multiplied a fraction by its common denominator, isn't it going to result in an integer? Meaning not a fraction anymore. So for instance, if I had 4/3 times 3, the 3's cancel, leaving you with 4. So if we multiply by the common denominator, we're actually going to eliminate fractions. and then we just move forward and solve the equation as normal, which is really nice. It's a great tool. It makes things super, super fast and quick if you use that strategy. I'm going to show you what it looks like. It might take a little bit of practice, trying it. I have some practice problems that you can do as well if you wanted something outside of the Lumen. But try it, please try it, because it's going to save you a lot of time. So let me show you. So what I'd like us to do is rewrite this because we need some space. So negative 12/13b minus 2/3 is equal to 22. So I've rewritten the problem just to give you some room. Take a look at your fractions. Notice what your LCD is in this case. LCD, lowest common denominator. Your denominators are 13 and 3. So your common denominator is going to be found by taking 13 times 3, which is 39. So here's what I'm going to do. I'm going to note that your LCD is 13 times 3, which is 39. That's your LCD. Rule number 3 says you must multiply every term by the same quantity. Here's your first term. Here's your second term. Here's your third term. I've packaged each term in parentheses. And now I'm going to multiply every term by a 39. Okay, I'm going to multiply every term by a 39. Now check this out. 13 can go into 39 3 times. So 13 goes into itself once. 13 goes into 39 3 times. Now if I read what's left, you will see this says 3 times negative 12b. 3 times negative 12b gives us negative 36b. And guess what? No more fraction. Let's do it again with our second term. 39 times 2/3. 3 goes into itself once and into 39 13 times. And now we have minus 13 times 2, which is going to be a minus 26. Lastly, we see that our paper reads 22 times 39, and that's going to give us 858. This is going to be an incredibly useful strategy to use. Anytime you have an equation with at least one fraction, we can multiply by the LCD to cancel fractions. Now at this point, all we have to do is solve. So I'm going to bring over the 26. Notice I have 1, 2, 3 terms. I want to bring over the 26, so I'm going to add it. The opposite operation, right? The opposite of a negative 26 is a positive 26. Those cancel each other out, leaving you with a 0. So I'm going to bring down the negative 36b, and I'm not going to write plus 0, because I know negative 36b plus 0 is still negative 36b. And then we have 858 plus 26, and that's going to give us 884. Last step, negative 36b is equal to 884. Negative 36 times b, the opposite of times is divide. So we divide both sides by negative 36. That leaves me with b is equal to negative, bring that negative up in front because it's a positive divided by a negative is still a negative, 884 over 36. Now, if you take a look at 884 and then the number 36, they're both even. So we actually can reduce both of those. So because they're even, we know we could divide by 2. But I want you to notice that we can actually divide by a little bit more than just a 2. We could divide by a 4 and see how that works. Let's start there and see how it works. So we're going to take the 884, we're going to divide it by 4, and that gives me negative 221 over, and then 36 divided by 4 is 9. Okay, so what I'd like us to do is leave our answer in improper fraction form. So Hannah, your answer is correct, but I'd like you to leave it in this form. Leave it in improper fraction form. Let me show you something with the calculator. So let's say that you took the negative 884 and you press ABC 36. Okay, negative 884 ABC 36, then you press enter. And you get negative 24 and 5 nines. That's okay. That's okay, Hannah. So negative 24 and 5 nines. But we want improper fraction form. So check this out. On your calculator, do you see in yellow here it says ABC to DE? That might be pretty small, but it says ABC, mixed number, to D over E, which is improper fraction. So press second ABC, enter. And we have our reduced fraction. Negative 221 over 9. That's what I'm looking for. Okay? Now, I'd like us to take a moment and go back to problem number 2. I'm going to rewrite it. 3/4 y is equal to negative 18. What if, instead of multiplying by the reciprocal, you said, I really like this LCD trick. I want to use it every single time. So I have an equation, it has one fraction in it, so I can multiply by the LCD. The only denominator we have is a 4, right? This negative 18 is over a 1, so you're not going to multiply by a 4 times an 18, that's crazy. So your common denominator is 4. So if we want, we could say the LCD is 4, just to make a note of it. We have 2 terms. So I'm going to multiply each term by the LCD. Notice what happens here. Numerator for denominator. These will cancel. That leaves us with a 3y. And then we have negative 18 times 4, which gives us negative 72. At this point, I have 3 times y is equal to negative 72. So let's divide both sides by 3. And when we divide by 3, we get negative 24. Notice all the different strategies that we can take that will make life easier. I really, truly believe, and I'm going to say this directly to you, I truly believe that if you have an equation with one fraction or more, multiplying by the LCD is going to be a fantastic way to move through the problem with the greatest of ease. Okay? Practice doing that. That's my advice to you. If you want to save yourself if you want to save yourself some like headache or time or anything like that, try using the LCD, multiply every term in the equation by that LCD, and continue with the problem. I will tell you that you should always eliminate distribute to drop parentheses first if you had an equation with parentheses before you use this technique. Just like problem number 4. Let's take a look. So problem number 4, let's use 2 different ways to solve this problem. So what we can do, which is actually pretty cool, is for our first technique, we could distribute, right? We're used to seeing things like this, and we would say, okay, let's distribute to drop parentheses. So why don't we use that as our first strategy? I'm going to distribute to drop parentheses. 2/3 times 5x. Remember, think of this whole number as being over a 1. So 2 over 3 times 5 over 1 is 10 over 3, right? So 10 over 3x, there's our first term. Plus 2 over 3 times 11, put that 11 over a 1 just so it's easier to see. 2 times 11 over 3 times 1. So it's going to be 22 over 3. And that's equal to 16. All right? At this point, I would recommend practice using your LCD. First, identify the number of terms you have. We have 1, 2, 3 terms. Take each of those terms and place them in parentheses. Let's make a note of what the LCD is. So the LCD in this case is 3. If you guessed 3, that's fantastic. Look at your denominators. They're both 3, so the LCD is definitely just 3. If you said 6, or if you said 9, or if you said 12, or any of those things, those will work. It's not a problem. As long as you're multiplying everything by the same quantity, that's totally fine. But try to find the path of least resistance if you can. So we're going to multiply every term by 3. Notice for our first term, our 3's are going to cancel. Numerator for denominator. That leaves me with 10x. Notice for our second term, the 3's are going to cancel. So it leaves us with 22. And then last but not least, we have 16 times 3, which is going to give us 48. At this point, all we have to do is take the steps that we're familiar with in solving these problems, or this problem. 10x plus 22 is equal to 48. Let's subtract 22 so that we can get it away from the term we're trying to isolate. Always move terms away from the term you're trying to isolate. These cancel each other out. It leaves you with a 0, but again, I don't want to write 0 here because 10x plus 0 is simply 10x. Then we have 48 take away 22, which gives me 26. Lastly, I'm going to divide by 10. And notice they're both even. So 26 over 10, I can definitely divide a 2 out of both. If I divide a 2 out of both, that leaves me with 13 fifths. So Hannah and Kayla, you're exactly correct. We divide by 2 and we get 13 fifths. This strategy is the one that I would recommend. Okay, this is the one that I would recommend greatly. I will show you an alternative, but I really recommend that you simply go through this process. So to sum, distribute to drop parentheses. If you have fractions, multiply by the LCD to cancel fractions, and then solve the equation. Distribute to drop, multiply by the LCD, solve. Okay? Those are the 3 things that I want you to consider. You don't have to do it that way, but I feel like it would be the easiest. And the students who have used this technique tend to get these questions right all the time. And it's with the greatest of ease. Now I'm going to show you an alternative. You don't have to do this. You can look at it and be like, I want to take that out of my mind. I don't ever want to do it. That's fine. But I just want to show you the possibilities. Okay? It's important for you to understand what you're allowed to do. Okay? Take a look. For our second way of solving this problem, we have 2/3 times, again, 5x plus 11 is equal to 16. From the very beginning, I want you to notice we have 1, 2 terms. If I did not distribute, I have only 2 terms in this equation. I have a 2/3 times a package is equal to 16. So here's what we can do. I'm still going to multiply, but I'm going to put my first term in parentheses, and I'm going to put my second term in parentheses. Notice my coefficient of 2/3. My coefficient is the numeric part of a term. So my coefficient is 2/3. If I want to solve this quickly, and if I want to just get creative with it with the rules, I'm actually going to multiply by the reciprocal of 2/3. So I'm going to multiply by 3/2. What you do to one side, do to the other. Notice the 3's are going to cancel, leaving us with 1. 2's are going to cancel, leaving us with 1, which means we have 1 times 5x plus 11. If we have 1 times 5x plus 11, well, I simply have 5x plus 11. On the right-hand side of the equation, notice 2 goes into 16. 2 into itself once and into 16 8 times. And 8 times 3 is 24. In one step, I was able to eliminate the coefficient of our first term, which leaves us with the 5x plus 11. So at this point, I can now subtract the 11. I have 5x is equal to 13, and then I divide by 5. So while this second form or this second path is a lot faster, it's a lot quicker, it can also lead to many problems if you're not careful with how you do this. The other thing to consider is when I multiplied by the reciprocal, 3 over 2, I knew that it's going to reduce with the 16. If I multiplied by the reciprocal and it didn't reduce, it didn't cancel out a fraction, then it's not worth it to me, right? So there's a little bit of like a give and take here. You can use that strategy if you're actually eliminating fractions. But if you're not eliminating fractions, then there's no point in using this second strategy that I showed you. You're better off distributing to draw parentheses, multiply by the LCD, and solve. So kind of keep that in mind as you move through these problems, okay? But like I said, I urge you to do the first technique. Having said that, I want you all to try number 5. I would like you to distribute to draw parentheses, multiply every term by the LCD, and then solve. Here's number 5. We have 4/7 times 12x minus 7 plus 9 is equal to negative 25. I'm going to give you 2 minutes starting now. So I'm going to use the strategy that I recommended from our previous problem where we will distribute to drop parentheses first. We have 4 over 7 times 12x. Remember, if you would like, place that over 1 so it's easier to multiply in your mind, so to speak. So 4 over 7 times 12 over 1 is going to give us 48 over 7x. Next, we have 4 over 7 times negative 7. Again, place that over 1. We can recognize that these 7s are actually going to cancel. So 7 goes into 7 once, so 4 times negative 1 is negative 4. Then we have plus 9 is equal to negative 25. I personally would just combine these two real quick. You don't have to. It's just something that I see as, it's just my own personal style of kind of cleaning things up as I go along. You don't have to. Yes, Hannah, it's totally okay if you subtracted the 9 and then added the 4. Totally, totally cool. It's also okay if you multiplied every term by 7 now. So really, it depends on your own personal style. What I will do is I will say, well, I know that negative 4 plus 9 is a positive 5. So I have 48 over 7x plus 5 is equal to negative 25. Oh, Hannah, excellent question. Hannah asks if we could subtract the 9 first before distributing. Yes, absolutely, you totally can. So you could totally just subtract the 9, bring it over, and then distribute, etc. Rhea, you asked a great question. Where in the heck did the negative 4 come from? Well, let's do a little bit of side work. If we had, and I'm going to put this here, so side work. When we had 4/7 times a negative 7 over 1, I noticed that the 7s reduced. So 7 goes into 7 once, right? And that left us with a negative 4 over 1, which is just a negative 4. So that's how I got the negative 4, Rhea. All right, perfect. So again, at this point, you could say, let's multiply every term by a 7. But I'm still not going to do that. I'm still not going to do that only because of my personal style. I'm actually going to just bring the 5 over. So I'm going to subtract the 5. And that leaves me with 48 over 7x is equal to negative 30. I only chose to do that because I knew that those were going to be very easy to combine. So I figure, why not just move everything over that I can combine and clean things up before I go into multiplying by the LCD. Just a personal preference. You don't have to do it that way. At this point, I now only have 2 terms. My LCD is 7, so I'm going to multiply each term by 7. So if it helps, we can write LCD is equal to 7, just as like a little side note. When we multiply our first term by 7, we notice that they're going to divide out. So 7 into 7 is once. That leaves us with, and I'm just going to move this like so, that leaves us with 48x is equal to, and then we have a negative 30 times 7. We just read it exactly as we see it. So negative 30 times 7 is a negative 210. Last but not least, we say, oh, this is 48 times x. So in order to solve for x, we must do the opposite, which is to divide. So we're going to divide by 48. 48 divided by 48 is 1, but 1x is the same as x. And then we have a negative 210 over 48. If we take the negative 210 over 48 and we reduce this, notice that we can actually divide both sides by 6, it turns out. I used my calculator to reduce this, so I noticed that I'm going to have a negative 35 over 8, and that's because I divided both of these by a 6. So we have negative 35 over 8. If that was your answer, excellent work on breaking this problem down. I'm almost pretty certain that you and I had slightly different paths towards that answer, but the bottom line is, as long as you apply the rules that you've been learning and you get that final answer, then you're good to go, right? And that's totally cool. All right, last problem. Do this one on your own. Go ahead and throw your answer into the chat, and then we'll call it a day. Negative 3/5 times 4x plus 10 minus 2/3 equals 11. Give us your best shot, starting now. Okay, so let's take a look at this problem. So the first thing you will want to do is to distribute to drop parentheses. And then, as Claire suggested, we're going to multiply by 15 because that is our LCD. So check this out. So we are going to distribute this negative 3/5. Negative 3/5 times 4x is going to be negative 12 over 5. So negative 12 over 5x. Next, we have negative 3/5 times 10. 5 goes into 10 twice, so this gives us negative 6. Okay? If you want, do some side work. Negative 3/5 times 10, that's a negative 6. Then we have minus 2/3, and we have equals 11. Now, we have to figure out how many terms we have. 1, 2, 3, 4. Claire said that our LCD is 15. So if you would like, at this point, we could take each term, put it in parentheses, including the 11, Claire. The rule is you have to multiply every term in the equation by the same value. So what you'll want to do is multiply every term by 15. Kevin, so because that strategy is not working out too well, use this strategy instead. Distribute to drop, then multiply by the LCD. So notice in our first term, 5 goes into 15 3 times. 3 times a negative 12x is a negative 36x. Then we have 15 times 6. So negative 15 times 6 is minus 90. 3 goes into 15, denominator into numerator, that's 5 times, it's minus 10. And then 11 times 15 is 165. Let's finish this problem out. Negative 36x minus 100 is equal to 165. And then we add 100. Opposite operation to move to the opposite side. So we have negative 36x is equal to 265. Then we divide by negative 36. Notice these cancel. Oop. It leaves us with x is equal to negative 265 over 36. If you're unsure whether or not it reduces, just go ahead and throw that into your calculator. It actually does not reduce, so that is your final answer. Excellent work. Keep in mind, first thing, this is the end of week 3, so we're moving right along. And the second thing is you may want to rewatch this video. You may want to listen to the steps again, try those steps on your own once more. It's okay to rewatch this to make sure that you're understanding. That's the whole point of recording it and placing it somewhere where it's easily accessible. Okay? I hope you enjoyed today's class. All right, everyone, excellent work today. I apologize for keeping you a few extra minutes. We're just having too much fun. All right, see you. Be safe. Have a great weekend. I'll see you Monday. Bye.